Hello, my dear students. Today we are going to study what is degree of freedom. So before that, I'm going to overview of some concept from the vibrations, in which the Newton's law of motion is very important. The first law of it is if there are no forces acting upon a particle, then the particle will move in a straight line with a constant velocity. The second law is very important for the vibration to determine the vibration equations. This second law is very important. A particle acted upon by a force moves so that the force vector is equal to the time rate of change of the linear momentum vector. So it can be say that like F external means external force must be equals to the rate of change of linear momentum of the system. The third law is also known as the reaction law. When two particles exerts forces upon one another, the forces lie along the line joining the particles and the corresponding force vector are the negative of each other. So next, the definition for the degree of freedom. It is the minimum number of independent coordinates required to determine completely the position of all the parts of a system at any instant of a time defines the degree of freedom of the system. A single degree of freedom system requires only one coordinate to describe its position at any instant of the time. Or and the same way, the second degree of freedom system requires only two coordinates to describe its position at any instant. At the same way, we can determine more degree of freedom system. So we are going to see the example of the single degree of freedom system in the next slide. Also, here we can see this. There is a mass which is disturbing by a motion in the downward direction. Its displacement is x, which is independent of other any other elements. So there is only one independent variable, that is x, which is independent upon the time only. So this is the single of degree of freedom system. Now there is a rotor which is twisted, which is having an angular displacement of theta, which is independent of another coordinate system. So this is also a single degree of freedom system. Here we can see in the next slide that example of single degree of freedom system. Here the simple pendulum is taking in the example. So for the simple pendulum in the figure, the motion can be stated either in terms of theta or x and y. If the coordinate x and y are used to describe the motion, it must be recognized that these coordinates are not independent. We can see this if this is the x and this is y, and this x is dependent with the. So if we see this x displacement of this mass in the horizontal direction is x, and in the vertical direction, if you are taking this this is the origin o, here it is the origin, and the y displacement is like vertical displacement is y and horizontal displacement is x. But we can see if we are taking the origin as this point, so the vertical displacement is L into 1 minus cos theta. We are taking the component of this L as this is the L cos theta and this is L sin theta. So this is the L sin theta, x equals to L sin theta, and this y is L cos theta. So we can see this x and y is only depending upon the theta. So the theta is the only coordinate which is independent, but x and y are dependent, because this is the Pythagoras formula. X square plus y square equals to L square, means this is x square, this is y square, this base square plus perpendicular square equals to hypotenuse square. So this x and y is related with this equation, so x is depending on the y. So where L is the constant length of the pendulum, thus any one coordinate can describe the motion of the pendulum. In this example, so if it is this, the motion of this mass is only dependent upon the one coordinate, that is x, or we can choose a y, then x is dependent. If we choose y x as an independent, then y will be dependent variable. So this is only there is only one independent variable for this motion. So moving further, for the two degree of freedom system. some example of two degree of freedom system are shown in the figure. The first figure shows a two mass and two spring system that is described by a two linear coordinate x1 and x2. Here we can see this mass m1 is moving in the rightward direction with a x1 displacement, or we can say it is a disturbance, and for this mass m2, x2 is the disturbance. So if you are checking that is x1 is depending upon the x2, no, because if we are putting the disturbance on this mass m2 by x2, this spring will not exhibit any motion. This spring will experiences the x2 displacement, but this spring will stop this the motion of this m1. So the this x1 will be always be independent from this x2, and this x2 is always independent from the x1. So there is a two independent variables, that is x1 and x2. So this is a second degree of freedom system example, and we can see this is the simple pendulum, and this mass is the simple mass spring system. So this will have a x coordinate, and this will have another x which is not if it is independent, then y is dependent. So there is only two independent. If we are taking from only one independent from x and y, because x square plus y square equals to l square, so x is independent, then y will be dependent. So for this mass there is only one independent, and for this mass only x is independent. So there is only two independent variables. So this is also the example of two degree of freedom system. And here the angular displacement of this rotor is theta 2, and angular displacement of this rotor is theta 1, and this theta 1 is independent from this theta 2, and this theta 2 is independent from this theta 1, because the stiffness of this rotor can be different, and the stiffness of this rotor can be different. It is dependent upon the material and the geometrical properties of the any element of the system. So this is also a second degree of freedom system. The next one is the discrete and continuous system. So if we can see in this example, a large number of the practical system can be described using the finite number of degree of freedom system, such as the simple system shown in the previous slide. And the some systems, especially those involving continuous elastic members, have an infinite number of degree of freedom system, as shown in the figure, since the beam in the figure has an infinite number of mass points. So this beam can have a infinite, which are continuous. At every point there is a mass, and so the every mass will have a displacement which are independent. So since the beam is in the mass points, we need an infinite number of coordinates to specify its deflected configuration. The infinite number of coordinates define its elastic deflection curve. Thus the cantilever beam has an infinite number of degree of freedom system. So thank you for this lecture and listening this lecture, and I hope we have understood all the concept of degree of freedom system. So this is the basic concept for the degree of freedom system. Thank you.